So in statistics, we talk about different variables, am I right? Random variable X. In random variable X, we had different scenarios. One scenario was you have a discrete random variable, or this variable, like the number of students sitting in this class, it's countable. Then we learned that we have very important probability distribution that we called a binomial probability distribution. Then we said that, okay, not all random variables are countable. Like what? Like the volume, the area, the length of time. Those are examples of continuous random variable. So when you have continuous random variable, one important distribution is a normal distribution that we're going to discuss today. So a normal distribution is a continuous probability distribution for a random variable like X. And the graph of a normal distribution is a bell-shaped graph. It's a normal curve, and it has some important properties. First of all, the mean, median, and mode, so basically the center, if you use any measure like mean or median or mode, they're equal to each other. It's going to be the balancing point, all right? The balancing point for your graph. So for random variable X, you have your normal curve, and the balancing point, as you remember, it just balances the graph, balances the data, the center here. And we discussed different types of measure of center, right? Perfect. The normal curve is bell-shaped and it's symmetric with respect to the mean. So if we use a vertical line that exactly passes through the mean, and if we flip this, you're going to see the symmetry. The total area under the normal curve is equal to 1. But remember that when we talked about a binomial distribution, we had probabilities in percentage or in decimal form. So we say that, hey, the total area below the curve is 100%. Where does this 1 come from? You have 100%, going back to algebra, everybody. So if you have 100%, the meaning of that is you have 100 multiplied by 1 divided by 100. You can cancel out 100 and 100, you get 1. So the total area below the curve is equal to 1. Perfect. So let me move this a little bit so you can see 1. Here we go. So 100% or 1. The normal curve approaches but never touches x-axis. So this curve on the left and on the right, it never touches x-axis. It just keeps going, right? And the function defines this normal curve is 1 divided by sigma square root of 2 pi e to power negative x minus mu to power 2 divided by 2 sigma squared. You don't have to worry about this function. In our class, we're not going to directly use this function. What are we going to use instead? We're going to use our calculator. This function is built into our calculator, and we're going to learn how to use our calculator to compute different probabilities. And finally, for a continuous probability distribution, you can use a probability density function that we introduce. So we are a statistician, am I right? Some data, as we mentioned before, are confidential data. If I give you a random variable x representing, for example, the IQ score of all students, x is a continuous random variable. For confidentiality's sake, as a statistician, as a data scientist, you might not be interested in giving away these data to public. So what are you going to do? You're going to convert these into z-scores. z-score. So what is the transition? When we have a normal distribution for x values, we can convert these x values into z-score using this transition. We're going to take each x value, find the difference between x value and the mean of the data, and then divide that by the standard deviation. What does it give me? It gives me some new numerical values that we call z-scores. The standard normal distribution for z values, these are your z values, has the exact same shape. It's a bell-shaped graph. The area below the graph is also 100% or 1. For example, take a look at this center or mu here. Note that the center of x data values is mu. But when you are looking at the standard normal distribution, the center is 0. Why is that? What's the conversion look like? Okay, my x, our x is the mean. Am I right? Let us substitute that here into the formula. My x is the mean. So wherever you see x, you're going to write down mean. Mean minus, well, on the numerator, I have the exact same mean value. On the denominator, I have the standard deviation, SB. But mean minus mean is 0. 0 divided by standard deviation, 0 divided by any non-zero value is equal to 0. So from the mean, mu, in the normal distribution, we got 0 as the center in standard normal distribution. So as you can see, the standard normal distribution has mean equal to 0 and the standard deviation equals to 1. And again, the total area is 100% or 1. These are important things that we need to remember about the standard normal distribution.